Okay, so we've got the notion of subgroup. I'm just going to get a few things out of the way. There's two obvious or trivial subgroups, I guess. G itself is a subgroup of G. You can tell it is simply because the group operation written as a circle here is closed. So the fact that it's a subgroup follows from the group axioms. Also, for any group, the identity element is a subgroup of G. That's, well, it's still a trivial subgroup, but it's worth going through the rules. We'll do this one. We'll verify that this one's the case. So the first one says that if X is a member of H in this case is equal to just the set containing the identity element. If X is in H, then X minus 1 is in H. That's the first axiom. See how, when I'm thinking about this, I just write out the axiom again, and that helps me understand it. So in this case, the only X we've got is E. So if E is in H, then we are asking whether E minus 1 is in H. And we already know that E to minus 1 equals E, and we know that E is in H. So we satisfied the first rule. The second rule says that if X and Y are in H, then X, Y minus 1 is in H. And this is easy to verify too, because the only choices for X and Y we've got are E and E. And so we are asked to verify that E minus 1 is a member of H. And that equals E times E, because we know E minus 1 equals E, which is of course a member of your trivial subgroup H. So we've got, straight away, we've got two boring, but nevertheless they're nevertheless correct subgroups of G. The group itself and the set containing just the identity element. Kind of boring ones, but we'll do some more interesting ones now. Okay, I'm going to stop there.